Hey y'all, welcome. Yeah, so I have a really fun geometry problem that I'm going to first show you how to solve efficiently in a very cheap way, and then we're going to discuss the underlying concept or idea behind the problem using this visual. Yeah? Okay, cool. So we're told that the area, and that's what I mean by alpha, the area of triangle ABC, the right triangle here, is equal to 8, and then we're told that BC is equal to CD, and then we're asked for the area of this triangle above the right triangle. So first we're given that the area of this right triangle here that I'm shading is equal to 8, right? And the task is, well, knowing that, and then knowing that BC is equal to CD, we have to figure out the area of this triangle right above the right triangle, yeah? Okay, cool. Now, the cheap and efficient solution is this. Well, we can just pick the sides of triangle ABC so that its area is equal to 8. So like, if we say that like AB is equal to 4, then we'd have to say that BC is also 4. That way 1/2 base times height is going to be 8. That is, the area of the triangle is 8. And since this is a right triangle, both the base and the height are going to be the two legs, right? Okay, well, the base is going to be one of the legs and the height is going to be the other leg, right? Okay. But then because we know that BC is equal to CD, it means that CD is also 4, right? Okay, cool. Now, for triangle ACD, what we can do is use CD as the base and then use AB as an external altitude, right? We can think of AB as an external altitude for this triangle that's unshaded. And so then its area is going to also be 8. Yeah, so that's the cheap way to solve the problem. But the idea that it hits on, right, the underlying idea, which sounds kind of like very obvious but is a little bit deceptive, is this. Well, if two triangles have the same base and the same altitude, they have to have the same area. And you're like, duh. But let me demonstrate. So if we fix the base of a triangle so that it's like this length from A to B, and then we have that this line is parallel to this line. Well, saying this line is parallel to this line means that the vertical distance between the two lines is the same regardless of where we draw it. So if I draw a vertical distance here, it's going to be the same, right, as a vertical distance I draw here, and it's going to be the same in turn as a vertical distance I draw here. And of course, I can do this infinitely many times, right? Okay, now, if we do this, then I've just formed one triangle, and let's call it like ABC, I suppose. And then if we call this like D, then I can form another triangle, this time by doing this, right? And I will shade the new, I don't like that my lines are not very straight. So the new triangle that I just formed is this one, right? And then I can make another triangle, this one. And in fact, by drawing vertical distances anywhere, like here, anywhere, and then doing the same thing that I just did, I can create infinitely many triangles. And all those infinitely many triangles will have the same area because, well, in this triangle here, this is the base and the altitude is internal. But in this triangle here, this is the base and the altitude is external. But the altitudes are the same whether it's here or here, and the bases are the same also, and likewise over here. You get it. Yeah? Okay, cool. So triangles that have the same base and the same altitude have to have the same area. That's what we just demonstrated. Yeah? Okay, cool. Take care.